before we start, but we will start at exactly 12:30. We've got a lot to go through. I forgot to play my elevator music that I was gonna put up, so I need to make a note to remember that next time. Elevator music. All right, we're still waiting for others to come online. We'll start in 1 minute's time.
Is anybody talking?
Sarah, we're live, so we're just waiting for other people to come online before we start the seminar officially. All right, maybe I'll just kick it off then. So welcome everyone to Zoom and to our Stormwater Victoria webinar. I hope you're doing safe and well. I'm Tracy Pham, I'm the chair of the events subcommittee for Stormwater Victoria, and I'm gonna be your MC for this event today. The event is on smart technology, talking tanks for water conservation, flood management, and environmental baseflow. I'd like to start the seminar by acknowledging and paying my respects to the Wurundjeri people of the Kulin Nation, who are the traditional owners of the custodians of the land where this seminar is based. I would like to pay my respects to their elders past, present, and emerging, and acknowledge all Aboriginal and Torres Strait Islanders who are here today. So this session is being recorded, so please let us know if you have any concerns about that. You can let us know via the chat function below to SV, or you can send us an email. If you have any questions for speakers, feel free to ask them in the Q&A panel below, and that's located in the Zoom toolbox that should be below. So the previous few webinars that we've done are now available on the Stormwater Victoria website, and the Q&A discussion paper is also there. So please check that out. So today's topic is on smart technology. Smart technology and its use in the stormwater space. We provide an overview of talking tanks and their wide use in Melbourne. And we unpacked 3 key areas where smart tanks are currently being used. First, we look at its use in Aquarevo development. Next, we look at how it's being used for flood mitigation by Knox City Council. And finally, how it's being used to manage base flows in Monbulk Creek in the Yarra Ranges. So this week we're trialing a different format for the webinar. I will hand it over to Jamie Tayton, who's the SV president, and she'll do her president's address, and following that is the sponsors video. I will then introduce the other panelists that are here today. So the presentation was a collaborative effort between Dr. David Bergman, Sir Nath Tavate, and Dr. Beth Wallace. However, only David will be presenting the material, and that will go for about 30 minutes. Afterwards, we will have a Q&A session and discussion for about 15 minutes on the material that was presented. That will bring us to formal closing by 1:30. We will keep the session live for some informal networking and any additional Q&A that we weren't able to address in that time. You can network with us using the chat functions or message anyone in the webinar. Just make sure that you sending your message to the correct person, or if it's to everyone, make sure that you've set it so that it's that everyone will see that message. All right, over to you, Jamie. Jamie, are you on mute?
Unmute. Oh, did I do it? Can you hear me now?
Yes, I can hear you now.
Excellent. See, we all have problems. Anyway, welcome. First, thanks to IOTA for sponsoring this event. They really are the perfect partner for this with their innovative and amazing talking tank technology, which I think you're about to hear more of after me. So I won't steal their thunder, but without sponsors like IOTA, we'd need to consider how we offer these great free webinars. Today, we've had over 300 people nationally register for this event. So it's some great exposure for anyone looking to reach a broader or wider audience. If anyone here wants to support webinars like this, or the association in general, get in touch and we can talk about how you can get involved. So it's membership renewal time for us. Woohoo! Keen to see the renewals roll in and explore what new people want to hear from us and get involved in sessions like this. If you'd like to know more, head to our website and check it out. We also have our AGM coming up, and while executive positions are 2-year positions with 1 year to go, so you've got me for a whole nother year, we'll be renewing our general committee roles. Hopefully we'll have much of our existing team stay on and keep the vibe and culture rolling, but also keen to see some new fresh faces and some new ideas stepping in to be part of the action. We have a lot planned over the next 12 months and very keen to see who wants to help out. I think Tracy's going to touch on a little bit of this later on, so I'll leave the rest to her. So, another day, another lockdown, a change in rules and uncertainty and what we can and can't do. I, for one, have been getting quite lost in what might be allowed to do from day to day. Another week of school holidays and back to homeschooling. Flexible learning, actually, that I've just been corrected on that. So our households are again morphing and changing with our environment, just like our creeks and waterways are forced to morph and change with the new directly connected imperviousness we're putting that way. And without intervention, our waterways can't go back either. So we're forced to adapt and change. So as we are forced to adapt and change, I want you to think about how we're forcing our waterways to adapt and change to suit human habitation. I want you to think about what you can do to reduce the impact of waterway health in your sphere. We're also about to hear about how talking tanks can soften the blow on development in some ways, but I'm certain there are much more ideas out there yet tapped to be implemented. I'm keen to see what our community can do to make a difference. For now, let's hear about the latest in smart water tanks. Well, clever tanks, multi-use tanks, they really are a fascinating twist on a time-old asset. Thank you to our speakers and our panellists for your time and commitment today. I've personally been out to the Aquarevo site in its early construction. It's fascinating to see. Definitely a new approach to development and integrated design. You're setting the bar pretty high there, David. Thanks to everyone again, and I look forward to chatting to you soon. Thanks, Trace.
Thanks, Jamie. All right, we've just got a video.
Hi, my name's Sarah Last, Product Manager at IOTA. IOTA is a wholly owned subsidiary of Southeast Water. We commercialised and developed solutions that have been proven within their network so we can bring them to organisations like yours. IOTA provides an important commercialisation link between research and development activities in the broader market. Our solutions have been used by organisations in all corners of the world to provide improved visibility and control over wastewater and water networks. It's IOTA's goal to provide tools to our customers that enable them to improve customer experience, protect their environments, and operate more efficiently. IOTA's solutions integrate with a wide range of other technologies, including existing hardware, communications protocols, and platforms. By being technology agnostic, we enable our customers, like yourselves, to build smart networks that are going to work for their organisations, not just now, but also in the future. Our two solutions that are relevant to intelligent stormwater management are the Tank Talk and Advanced Blockade. Both of these solutions were built by a water authority for water authorities. The Tank Talk prevents rainwater tank overflow and preempts flooding. This industry-leading technology measures tank level and provides smart, intelligent, on-site stormwater detention systems, all from the office. Tank Talk is enabled by our smart Monbulk controller and via two-way communication provides both visibility and control over existing tank networks. The advanced blockade enables customers to view, detect, and then fix small problems in their sewer and stormwater networks before they become big issues, shifting from being reactive to predictive in intelligent spill monitoring and prevention. If you'd like to hear more about Hyota's smart solutions, please do visit our website at hyota.net.au or contact us directly. We look forward to hearing from you, and in the meantime, David, over to you.
Oh. All right, thanks for that. I'll just quickly introduce the panel that we've got today. So this presentation has been put together by Dr. David Bergman, Sanaith Tavate, Dr. Beth Wallace, and Daniel Shu. However, as I mentioned, only David will be presenting. So Dr. David Bergman is a Research and Development Manager with Southeast Water. He has a PhD in chemistry and has worked in a diverse range of organizations and industries, with experiences in product development from chemicals to detergents, food, and now water and wastewater. He also works with major universities, manages Southeast Water's intellectual property portfolio, and works with their commercial subsidiary, Iota. David has led the technical deliverables of Aquarevo, and his interests include alternative water resource recovery, solar energy options, and development of digital systems. On the Q&A panel, we have Sanaith Tavate, who is a qualified engineer who has worked in the stormwater and construction industries over the last 16 years. He is currently part of the stormwater team at Knox City Council, and his professional career includes capital projects delivery, stormwater and water sensitive urban design, strategical asset management, construction management, developments and program management in various Australian council. Also on the panel, we have Dr. Beth Wallace, who is the Water Management Officer with Yarra Ranges Council. Beth has a PhD in freshwater ecology and previously completed her postdoctoral research at the University of Melbourne. Beth developed the integrated water management plan for Yarra Ranges and was involved in major collaborative research project in the Little Stringy Bark Creek catchment. Beth's interests include translating research to on-ground outcomes, integrated water management, WSID, environmental sustainability, and stream ecology. We also have Daniel Chu on the panel, who was a PhD candidate at the Waterway Ecosystems Research Group at the University of Melbourne. His main research focused on how to apply smart real-time technology on stormwater control measures. Thank you all for being part of the panel and dedicating your time to the webinar and sharing your work with the industry. All right, over to you, David.
Thank you so much. And maybe Tracy, you can confirm I am sharing and that screen's coming up all right?
Yep, everything looks good.
Fantastic. Thank you so much. Thank you so much, everyone, for joining us today. Thank you, Stormwater Victoria, for the opportunity to present what we're doing across a wide range of partners with our smart tank technology, and thank you, Iota, as well, for sponsoring the session. I have the pleasure and pressure of actually presenting on behalf of a number of other people. So I will do my best to represent their projects, but they are available sitting on the panel later on to take all the tough questions later on. So thank you so much. So in terms of what we will cover today, Tracy already mentioned the majority of what we will cover, and really we're looking to share with you around how we're using smart tank technology and how we're trying to balance this multi objectives of water conservation, or in other words, supplying rainwater into homes for homeowners to use or businesses. The other objectives of flood management and taking the peak out of rainfall events, and also then the other of the multi-objectives to balance what can we do to supply environmental base flow and healthy waterways. And we'll go through a number of examples that are at various stages in their development cycle. So what is tank talk? Well, in one way I'll explain it is about making your rainwater tank smart. So as Jamie put it, a new take on a very old system. And rather than just letting your tank do its thing passively in a way that it's unmonitored and unknown as to how well it's working, we're able to make that tank active and smart. And so as a result, we can actually maximize the retention of a rainfall event in the tank, making sure it captures as much as possible. And as a result, then we can look to have an impact on reducing the amount of water and stormwater that's going into the local system, and also have an impact on how we're contributing to healthy local waterways. So what is it? Well, it's a box. It's an electronic box, hardware and software, currently sitting inside the Monbulk format that Sarah mentioned earlier. And that's that picture at the bottom right hand of the screen there. We have more than 6,000 of these Monbulks out. We use them for running our pressure sewer network down the Mornington Peninsula, and they're deployed in other parts of Australia and even overseas as well. So the tank talk sits inside that Monbulk at the moment. Tank talk is also a level sensor that goes inside the tank, and it's also then a valve, an actuating valve that we can control at the outlet of the rainwater tank. It can also be a pump whose power supply that we can control. And I'll give it an example of how that is working. So through the Monbulk technology, we're able to receive weather forecast information a day or further out, and we're able to make predictions about what kind of space we would like to make within the rainwater tank, and can preemptively discharge water from the rainwater tank to make space for it once the rainfall does arrive. So here's an example on the screen of a discharge happening and the days leading up to it. The blue line being the level of water in the rainwater tank, the green line being rainfall events that, as recorded at a local bureau rain gauge, not immediately on site, but nearby. So you can see, as on the left-hand side of that chart, there's a rainfall event on, I think that's the 11th of August. It fills the tank. There's another rainfall event. It fills the tank again. Each time the Monbulk technology is calculating whether that rainfall event can fit in. And in both of those occasions, it knew from the level in the tank plus the available roof space it was catching from, that it could fit that rainfall event in the tank. So preserving that water for the household demand. Further down towards the right-hand side of the chart, the tank talk device received weather forecast information that a significant rainfall event was happening. That little red blip is an indication that the valve has opened. You can see the blue line of the tank level decreasing, followed by the rainfall event that then refilled that tank again. And so the majority of that rainfall event was captured within that tank and was able to take that out of the stormwater system at the time of the rainfall event. We're beginning to apply this in a number of ways. It can be applied in the residential setting, and so we're rolling it out in our Aquarevo estate, which we will talk about shortly. It is finding application in office and apartment buildings. We've got it fitted on our own office block in Frankston at Water's Edge, and we have another apartment site in the Fisherman's Bend precinct that we're using as a pilot and a demonstration site as well for much more intense living. We'll talk about Knox and Monbulk Creek and how we're using that for nuisance flooding and for healthy waterways. and we will discuss those shortly. But really quickly, before we get there, I wanted to briefly talk about some of the research we're doing with Tim Fletcher's group, the Waterway Ecosystem Research Group, of which Daniel Zhu, our PhD student, is sitting on the panel today. So please throw all the hard questions at him at the end. And this has been a study that we've been doing for a number of years now, which has involved, it's primarily a modelling study, which has looked at taking real rainfall events, real demand, and demonstrating how we can best achieve these multi-objective outcomes of environmental flow, stormwater retention, and the household demand. And through Daniel's work, and he's published papers on this, we've been able to demonstrate that this is possible by the right tank size, the right catchment size, and setting the right thresholds for the system to operate within. It is possible, and it's also, we've developed the understanding of how to flex to favour one of those scenarios over the other. And the model, we can continue to use that. Daniel's also been in the process of actually testing out that model, and we have a fully equipped house, a real person's house in Caulfield, that has the tank talk set up and was prepared to let us add even more monitoring equipment to it so we can monitor all the ins and out, know the rainfall on site, and actually start to validate some of the outcomes of the model. And we simulate, more than simulate, we're actually doing stream flow releases on site. That's given us some very valuable learnings, and we're continuing to optimize that. So let's see if this video works. It's a very short video. Just Daniel happened to be on site knowing when a discharge was scheduled to happen. So this is a scheduled discharge simulating what we do into a stream flow. In this case, this was about a 5-litre discharge that was happening every hour. We've been able to decrease that amount, and that's part of the ongoing optimization, decreasing the amount down to 1 and 2 litres any hour. We can change the time frame of that. We can change when that happens during the day. So there's just an example of how we're validating the model in a real live environment, showing all the ins and outs. Further building on that research work, through our own experience and through Daniel's research work, we've really been able to, we've understood that it can be quite limiting only having a 1-day look ahead on the forecast period. Weather does change, we all understand that. And we've been working to improve the forecast accuracy and hence the data that Tank Talk is using to determine its discharges. So Daniel's been developing a modelling system that looks ahead 7 days and continues to optimize each day as that rolling 7-day forecast moves forward, and then across a 4 different scenarios, and then is looking as to how, if we were to apply that modeling outcome into a tank system, what would be the result on those multi-objectives that we've been talking about. So here's just an example output of the model, where on the left-hand, the top blue line is actual rainfall the model used, a real event. And we can see then the green line are scheduled discharges, actual discharges from the rainwater tank. On the left of that chart, the model decided that 7-day look ahead period, there was rain coming, it would do a release. Then actually, as the forecast changed, so it says forecast error there, it's more about a forecast change, decided to do another discharge. The whole time that green line is maintaining an environmental flow into the system, such that when the rainfall did actually happen, the red line is the overflow that would have happened from the tank without the smart system being in place. And there's the follow-up rainfall events, significant overflow from the tank if the smart system wasn't involved. And then it continues over to further down the track to returns to maintain that stream flow. So plenty of optimization still in the modeling, but we've been able to demonstrate and continue to improve, and we'll look to apply this 7-day advanced forecasting on some of the sites that we have. Questions on this, please point them to Daniel later in the panel session. I want to move on to Aquarevo. Aquarevo is probably our most progressed and advanced deployment of smart tanks in the real world. Briefly, maybe some people are sick of hearing about Aquarevo. We've been talking about it for a while, but really quickly, Aquarevo is a residential estate, Lyndhurst near Cranbourne, southeastern suburbs of Melbourne. 460 lots that have been jointly developed by Southeast Water and Villawood. There are now well over 100 houses being built and occupied on the estate. Each of those houses gets a rainwater tank supplied and maintained by Southeast Water. That rainwater tank provides rainwater for hot water for shower and bathing, and that system is monitored, controlled by our Monbulk technology as well, to make sure it's operating as it should, any alerts and alarms that we need to respond to. So here's some drone footage of the Aquarevo estate. This was taken late April. So some real quick features I'll point out. There's the extensive waterway running down the middle of the estate. This view is about half of the estate, the southern half of the estate. There's this much again, looking back the other end of the screen. That waterway is extensive, connects with at the top of the screen, the south end of the estate, the Marriott Waters waterway. So it actually creates an extensive, quite a few kilometres of waterway in that area. If you can see, there's a roundabout in the middle of that picture. Go to the top left of the screen to another roundabout. There's a house on the corner there, of the right of that roundabout. That is our house. That is the Aquarevo house that we continue to develop and test new technologies and new approaches and optimize things we do in Aquarevo. And I will hopefully get time to touch on that house later in the presentation. The other thing I'll draw your attention to on this slide is the size of the houses. We continue to be staggered by how big some of these houses are and how much of the block they continue to take up. The size of the house is not something we have control of, but what we do have control of is how much of the roof that they catch for rainwater. There is a minimum of 100 square metres that they must capture into their rainwater tank on their site. Otherwise, they don't have approval for their building and their house design to go ahead. So we are installing Tank Talk on site at Aquarevo. I'll move to the next one. We're now getting to a scale in Aquarevo where we're actually starting to see the system work and getting enough data as people are moving in, and some very preliminary data. We haven't shared this with anyone yet. We did some analysis in preparing for this presentation, and we'll continue to update this progressively. In May, for example, 62 millimetres fell on site in Aquarevo in May. We captured over 300 kilolitres of that in Aquarevo houses, in the tanks of Aquarevo, across 60 houses. We just looked at a subset of 60 houses in this particular piece of work. 176 kilolitres were actually, of that rainwater was actually used, and 61 kilolitres were discharged by Tank Talk, preempting a number of the rainfall events that then fell on site. Our analysis so far is actually showing us plenty of opportunity for improvement, which is great. What we get when we start to scale these kind of technologies, in that what we're saying, we have the potential to maybe use some of the 7-day look ahead forecasting that Daniel's working on. We still believe there's some significant overflow happening during these events. We'll look to try and adjust some different thresholds in that to capture more of that while still not leaving our homeowners short on the rainwater that they have for use in their hot water systems. I'm going to move on to then the work that's going on in Knox, and again, size on the panel for later in the session to take a number of these, and credit to Carolyn Cavello as well, who's no longer with Knox, who's had a vision for this as well for many years and has worked with us and others in trying to understand how to better treat a number of their catchments that are subject to nuisance flooding in an urban space that's very constrained about what they really can and can't do. In particular, we spent a lot of time studying what they call catchment 913. And it's really, that catchment is at the intersection of Burwood highways running from top left to bottom right. Fentree Gully Road runs in there. It's 1950s, 1960s kind of era for the residential space, which is at the top right. Flowing down to kind of the middle of the screen is same kind of era in industrial estate that is actually perpendicular to the stormwater flow. Then over to the left is more residents. All of this area impacted by nuisance flooding. And all of this area, or a lot of this area, very constrained about what can be done in terms of either putting in larger pipe work for stormwater or putting in second pipe work. Many of these houses are too close to an easement, would undermine the structures of a lot of these houses and even the commercial properties, making such a pipe work replacement process unbelievably expensive and difficult to do. Hence, really the need to look for something a step change, game changing into step change in thinking of how to approach this catchment. Hence the kind of coming together of our conversations over time. Well, rainwater tanks in this space, yes. Well, what about smart rainwater tanks? And so that over time got built into the modelling. So really the project was to then look at, can we apply smart technology in a fully developed and constrained flood catchment area. So this is perhaps a better way of showing that the upper side of that precinct or catchment is residential. There's this industrial precinct that then further leads into further residential in that space. So quite a bit of modelling has gone into this over quite a few years through water technology and engineering over the time. It is a very constrained catchment, as we see. It's at the foot of the Dandenongs. It's steep, what enters into that space. And really the conclusions that we reached and needed to look at was very much a multi-solution approach. Yes, looking at retention basins and redesigning those levees at sports grounds, some pit and pipe upgrades, rainwater tanks, yes, but really what kind of tipped it over in terms of making this a potential real solution was making those tanks smart, which meant that those tanks across the precinct would be empty or as empty as required to be able to capture the rainfall event and take stormwater out of the system at the time and reduce the flooding potential. So a couple quick modelling outputs. Again, any questions on these, point these at the panelists at the end. So just two of these. This is actually demonstrating that through the things I mentioned, retention basins, bunds, and rainwater tanks in the residential area at the top right of that did improve the depth reduction of flooding. So we can see that in the colours, that's depth reduction. Did have an impact in the residential area and the industrial area. What made a greater difference was when all those initiatives plus the smart tanks were extended into the industrial zone. A lot of hard surfaces, a lot of roof space, a lot of underutilised storm water in that area. So tanks and smart tanks in that space was then able to extend that flood depth reduction all the way down into the residential area below that area as well. So we're seeing a significant space in that area being able to be positively impacted by this multi-solution approach. So where are we at in this one at the moment? Yes, Knox is at the capital approval stage. We're also at we have a further brief out with Alluvium Consulting on this one at the moment, and that is around what are the possible governance arrangements around this. We've got, and that's the great thing that's got us to this point, very much a multi-partner approach to this. Knox, Melbourne Water, and Southeast Water is the water utility in this space. Governance ongoing, how are we going to own it, operate it, maintain it? For example, if this is a way around replacing some traditional assets like the pipe upgrades, should the traditional asset owner pay for it? Should Knox pay for it? Should the ratepayer pay for it? Should the technology provider pay for it and maintain it ongoing? So Alluvium are consulting, working up a number of options for us to consider in this space, as well as customer strategies. We need to maximize the uptake and the understanding of how these tanks can be used to make sure this is a successful deployment. And that report, I think, is literally due any day, or the first draft of that. I'll move on to then the next example being Monbulk Creek, which has been a collaborative approach with Yarra Ranges City Council, Melbourne Water, and the Water and Tim Fletcher's Waterway Ecosystem Research Group, the WERG. And we've been, this has been one of the outcomes from ADELP's Integrated Water Management Forums, and is also within the Healthy Waterways strategy. It's a priority of Melbourne Water's Healthy Waterways strategy. And really what we're trying to achieve is how can we use all our usual approaches with some smart technology to ensure a healthy habitat, healthy stream flows, which just happen to be inhabited by a platypus population, and how can we maintain that and assure that well into the future. So here's the catchment and a number of other catchments in that area. Monbulk Creek is both above and below Belgrave within the Dandenong Ranges, and it ultimately flows down into Dandenong Creek catchment there. Another representation of this catchment, so the red highlights the roof spaces, so you can very much see where people live in this catchment. The top part of the catchment is quite unpopulated and forested. The lower part of the catchment identified there is well populated and has been for a while. The other things to highlight, and we'll be talking about these later too, is the potential additional lakes that are in this space, and our ability to actually use these within the overall program to try and influence the flows that we need to do. So the overall objective in this space, really look at how we can provide and assure appropriate stormwater and environmental flows to protect the habitat and environment around Monbulk Creek, and that habitat environment of the platypuses that are there. Forgot to mention, platypuses are extensively through Monbulk Creek, and there have even been reported sightings of further down into Rowville in that kind of system. An important area for us to protect. So the objective is to really, the second objective, to develop and demonstrate a proof of concept of how we can actively manage an urban stream flow, such as Monbulk Creek, through the use of technology, through assets in the public and the private realm, to demonstrate we can protect a habitat like this. Now, this is actually, this is one of my favourite slides of all time. Not quite sure why, but I really enjoy looking at this slide and understanding what it's saying. So credit to Melbourne Water and the work that they've done in this space. So this is a representation of a typical stream flow of a potentially platypus inhabited environment. And so what it really is showing that the green zones are obviously good in terms of stream flow. And what we want to avoid are those red zones in the high flow area that are obviously destructive on the habitat, and also detrimental to the habits of the platypus. Similarly, we want to avoid the red zones at the low end, where there isn't enough water, and that starts to impact the food sources of the platypus, the spaces that it can live and forage amongst. And we want to make sure that through the use of, good stormwater practices, through the use of technology, we're seeing how we can take the tops off those peak events, as well as then even out the troughs at the bottom to give much more consistent flow. So the platypus, they can breed, they can feed, and those juveniles can grow up to be healthy and continue the cycle. Sorry for a frighteningly messy slide, but the point here is through the University of Melbourne guys, their initial modelling, they were able to form a view that yes, this can work if we're using rainwater tanks, smart equipped rainwater tanks across that catchment, as well as controlling the water that is in a couple of the largest storages within the area. So the Birdsland Retarding Basin and Belgrave Lake as well. And so by using this combined strategy of the rainwater tanks and these large basins, we believe that we can take the peaks out of those rainwater events and then use the water to continue to provide the environmental flows, while still balancing, providing enough water for good amenity and recreation. And there's obviously an extensive piece of community consultation we need to go to here, because these are effectively community assets. I'm sure they don't want to see empty lakes at Belgrave Lake. They still want to be able to use them. So what is the right amount of water that they would accept not being in there in summertime, so that platypus can be protected further downstream? And what we'll be doing in this space, we'll be using the same tank talk technology and control systems to control the amount of water and amount of the level and volume and the amount that is being released from these larger storages as well. Currently where we're at the moment is we are looking for some pilot sites for the tank talk technology, just demonstration on assets in that area. Melbourne Water are doing the functional design for those larger, for the release mechanism, those larger storages, and we're looking for a grant, applying for a grant for the Uni of Melbourne guys to continue to research and study the results of what we're doing. The last thing I will touch on is just an opportunity that we're continuing to work on is through our house at Aquarevo. Really, how can we use smart tanks for greening and cooling? And so the feedback we often get is, well, you're releasing this rainwater into the stormwater system. What a waste. Homeowners think we're stealing their water from their rainwater tanks and releasing it to stormwater. But if we're able to use those tanks, the rainwater that's in those tanks, to also contribute towards irrigation around their home and potential cooling around their home, we think they will get an additional benefit from using that stormwater on site and using it in a way that makes for greener, cooler homes. So we're collaborating with a different group at Melbourne Uni to study the site. See on the screen here, we've got monitoring stations in place, our own sensor network that will feed back into the one box on site, so that our one box can actually control where the irrigation needs to be, where the misting and cooling needs to be, so that that house will be a cooler place to be. So instead of discharging its stormwater private to a rainfall event, probably using Daniel's 7-day look ahead, and even including heat waves as well, we'll look to use that water around the home in the smartest way possible. In terms of my time, I'll be wrapping up here. I was going to briefly mention Fisherman's Bend, but it will be used. The plan is to use within that environment as just one of the possible solutions there as well. So just to wrap up, to give you plenty of time to interrogate our panelists, really where this the ability to manage this multi-objective approach of water supply, flood management, environmental baseflow, we believe requires a smart approach, and the enabler being putting smart tanks on the more conventional rainwater tanks and other storage assets in combination with other of the WUSIT approaches we're becoming more and more familiar with. So far on all these projects, you can see that partnerships are key, who we're working with, trying to work out and achieve the benefits for everyone involved. And then as an outcome of that, what's the right way for the governance and engagement of the customer in that are key outcomes that are coming through now. So the final slide I'll leave on screen just to acknowledge the huge number of contributors to the work so far, and a number of them are sitting on the panel today, eagerly waiting for your questions. Thanks so much.
Thanks, David. All right, I'll just share my screen. I've got a few questions. I think I might start with Daniel. Let's see, I'll just quickly share this thing first. Share. All right, I think I'm going to start with Daniel because you brought him up first, David. So Daniel,
Yep.
Is there anything that really interesting that you found in your research that wasn't yet hasn't been discussed?
Yeah, I think David has basically touched most of the interesting bits, and especially the recent finding we looking at 7-day forecast. That's been probably the most exciting thing in the past few months, because by employing these advanced forecast data, we be able to further enhance the benefits of these smart tanks.
Yeah, and so that work that you've been doing, how long has that been going on for?
Oh, we've been testing and designing the system since September last year, and we are trying to we basically get a really good understanding of all the scenario we tested, and trying to optimize it, trying to get the best performance for different aid. Because basically, if you're looking at the multi-objectives, obviously you want to explore different benefits. So you prefer to restore more environment flows, or you're looking at more flooding mitigation performance? So yeah, we're getting good understanding, and we're trying to also publishing a paper in a really good journal recently.
Okay, yeah. And then in terms of next steps, what are your key next steps?
Yep. So yeah, that's really good question. So especially looking at a couple of projects that David Bergman was talking about, I think probably the most interesting next step would be looking at more networks. So how we can operate this system even more smarter. So saying, in a very adaptive network way.
Cool. David, do you have anything to add to that, or you're happy with that?
No, Daniel's answered that well. I'll just, in terms of what next for us, it is that networked approach, and really Daniel's work will next focus on the modelling that we'll use to optimise. And it gets really complex at this point when you're talking about 500 tanks in a particular catchment. Which one do you let go first? For the right multi-objective outcome. So Daniel's work been complex enough already? It's about to get really complicated.
Yeah, so I noted that in the second section of the presentation, it was to do with industrial catchments and how effective it is to use them to meet your objectives. So I guess, is that something that you're going to be looking at into more detail? Like, okay, we've got this catchment, it's got a breakup of, residential here, there's a, thing going on here.
Yep.
Which of these catchments are going to be best for optimization?
Yeah, that's right. So just using the example that Dave gave in the Aquarevo project. So saying you're operating all different tanks, right? The governance model is quite important, because now we're assuming, okay, the utility or water authority get the control of the tanks. So you say we're going to apply, say, in the whole Melbourne region, let's say, obviously some of the residents probably don't want to open the valve to release some water because they think, oh, we've losing some water, although our study showing it's not quite a lot. But there will be a case, we want to control some tanks, but the tank didn't want to cooperate. So in that way, you will have to manage to get a smart network control to compensate those people who don't want to contribute. That's just probably a very brief example.
Yeah, and so that sounds very complicated. Like if you're going through each tank, each house, each household, and asking each person, do you want to participate? How do you see like managing all this? How are you going with it? Is it, what are your approaches towards it?
Yeah,
maybe I'll touch on that, and potentially I might get Si to throw in on that as well. Certainly in Aquarevo, it's been easy because when homeowners signed up, they knew what they were signing up for. Once the system is in, the monitoring of it, that's all done remotely through the one box. We know if it's working. We know if it's how much they're using it. We even know if it's been disconnected. We know if we need to send someone out to service and maintain it. So certainly that awareness of if it's working or not, we know that. Maybe I'll invite Si to share maybe some of his thoughts and Knox's thoughts about that kind of possible government governance arrangements.
Thank you, David, and thanks for acknowledging Caroline before, as she is a main contributor to this work, as you know. And what we discuss is, because we are looking at mainly established area, it's really challenging for us to, get the community on board, especially the residents who has established houses in the catchment. So what we're trying to do is when the residents try and subdivide the house, we may put it into planning permit conditions to have those tanks installed and utilized by the residents. And also, we are planning to see how we can implement that on having that, stated on section 32, so that it gets transferred from one owner to the next, and they know what are the, what implications they have for maintenance of the tank and how it's performing. So that's what we are looking at doing now.
Okay, and similarly, what happens after the maintenance period for the smart tank systems have elapsed? Is there further maintenance agreements that you need to offer to residents? Like what happens if they decide, oh, I don't want this, and they just take it out?
Well, that's what we discussed, we should have that noted in section 32 that residents have to maintain that ongoing. It's not, they cannot remove that. And we were looking at, either Southeast Water as a water authority or Melbourne Water can, monitor it on yearly or, once in a 3 years basis to just see that everything is performing as per what we think it is, and take it on from there.
So I think what we'll find is, so the report that Alluvium are working on us for a moment, at the moment, we're hoping to see a number of possible governance models put forward in there, and we envisage any number of could potentially work for us. There is an ongoing model where the water utility or its commercial arm, such as we happen to have IOTA, would do the ongoing maintenance around that, monitoring and maintenance of it. That generally there's a cost associated with doing that, so it's about working about where, and it's not a huge cost to maintain a system like this with the ongoing, because of the monitoring is there. The remote monitoring is there. It's just where might that cost sit, and if there is a business case sitting behind that, as what we think is there in the Knox situation, the cost of putting in larger pipes or a second pipe is just cost prohibitive and also just not feasible. It changes the business case that you're comparing it to, and an ongoing maintenance cost potentially looks quite cheap in the scheme of things.
Yeah, so if I may jump in there, David, so what we are doing at Knox currently is Knox is, providing the funds for the upgrade of the pits and pipes in that area, and also looking at open spaces to, cater for that additional flow, and you providing that integrated water management solution. Cannot be completed without those tanks. So we will see if there's any funding through DELP or Southeast Water. That governance model will define that, as what David mentioned before. Once that's established, we can then utilize that and see how we can provide those tanks to the residents and take it further from there. It's as simple as currently the Victorian government or Australian government is providing the solar panels to the residents, where the solar panels are given the rebate and then maintained by the homeowners, and also they were checked by the Solar Victoria. So if we can do something like that, then that will be beneficial.
Okay, and like on the back of that, what have you had any feedback from homeowners, either in Aquarevo or within Knox City Council, about how they're, I guess, any feedback about those tanks, talking tanks tech?
I'll talk about Aquarevo, because that's the site where we're starting to scale. And generally, very little feedback. So we actually take that as a good thing. Homeowners and customers and ratepayers generally only give you feedback when it's a problem. So we've had very little feedback, which is a positive. We've had some feedback on, I said some of those houses are unbelievably large within Aquarevo that are being built, and some very large families in those houses as well. So we've had some very large users in that space. So we've had to go in and really do some communication and education with them about what are the constraints of the system, what it was actually designed to do, and in a very small number of cases make some minor modifications.
All right, I've got a question for you, Sai. Oh, that's not good. Hello? Oh,
Yeah.
Sai, can you hear me?
Yeah, I can.
Okay, great. I've got a quick question for you regarding the flooding, flood mitigation and options, not options, the flood mitigation image. So David showed that was the 1%, but I imagine that the tank technology would be more effective at flood mitigation objectives in the smaller storm events. What have you done any additional modeling to show that, or?
Yes, so we've done 1 in 5 years ARI and 1 in 10 as well, along with 1%. And what we can see is 6% reduction in 1 in 5, and the greatest we could achieve with the climate change included is 10.5% reduction. So that's a considerable reduction in flood.
Yeah, and that was for that area. Do you think that it'll be expanded towards other areas of Knox?
Yeah, this is a test case. So once we confirm that there are benefits, and which we have already seen, then we will certainly look at the other areas in the later stages. Yes.
Okay, cool. And I've got one for Beth, if she's on. I haven't heard much from her, so I thought I'll throw one to her. I've got one. In discussing the benefits of environmental flows, have specific conversations occurred with traditional custodians to understand whether there are cultural flows for significant areas along Monbulk and Ferny Creeks?
Yes, that's a really good question. So far we're fairly early days with our project in Monbulk Creek, and the most of the modelling has looked at the physical flow, the physical environment, and the environmental flows that are required for particularly the platypus as a bit of an indicator species for the health of the ecosystem. The next phase would be to actually start engaging with stakeholders, and that's where we would seek to engage with the traditional owners as well. And Yarra Ranges Council, we do have an officer specifically who does have close connections with the Indigenous people of the area, and so I think that would be something that would be really good to look at as the next phase.
Okay, I have another question about hydrology. So is hydrology the only problem facing platypus habitat and breeding in that area? Are there other barriers downstream, such as sediments, movement and all that kind of stuff?
I know that Melbourne Water is looking at Monbulk Creek in a more holistic manner in terms of health for platypus, and so hydrology obviously is a really key factor, but because it particularly how it impacts the wetted area of the bed of the stream, and because that has a direct impact on the food availability for the platypus. But I know they're also looking at the streamside vegetation as something that we can also look at trying to reinstate, particularly as we get further downstream past Birdsland Reserve. There's sort of some rural areas where we could be doing more revegetation. We have very active community in that area who are really keen to protect the platypus. So there's a bit of education going on around things like dog owners and controlling their dog around the waterway, because we know that dogs can be a threat to platypus as well. So there are a number of factors that we would look at all at once to try to improve conditions for platypus in Monbulk Creek.
Okay, thanks, Beth. So that brings us to 1:30, and that concludes the formal part of the webinar. Please check out the social distant events that we've got coming up. So next Thursday, these are within the stormwater industry. So not run by us, but run by other adjacent organisations. So we've got Stormwater Queensland's webinar next week, and that's around Manning's roughness in channels. The following week on the Clearwater are hosting a webinar on strengthening cross-sector collaboration. And then that will bring us to August, where we will have our AGM, annual general meeting. Please attend these events if you can make it. And I'll send out some more info and details on the annual general meeting later on. As always, if you can think, please suggest any future topics that you're keen to see. So speaker gifts this week are donations to WaterAid Australia, which goes towards getting clean water and facilities to communities that don't have them. Thanks again, Jess and Contessa, for putting this together. And thanks for joining us. Please stick around for the informal networking part of the webinar if you're free. Otherwise, we'll see you next time. And please make sure that you're messaging the person you want to message in that panel. Well, actually, we have a lot of questions still left to go. I'm not sure if you're interested in that. Maybe let's have a look. So, do you think the costs of control systems, including human resources, will reduce as the technology is refined? I think that one, maybe that's one Daniel, not Daniel or David, you could answer that one.
Oh, absolutely. It's the direct answer to that question. There's a couple of reasons behind that. Any of the electronics behind it, as anything, as you get scale in any kind of volume, they get cheaper to make. The components get cheaper to buy. The devices get cheaper to make. Things like the over-the-air communications networks just continue to get cheaper and cheaper to operate, particularly with a lot of the IoT-based communications, so narrowband and LoRa, much more specific to devices and IoT networks. They are heaps cheaper than using, like the kind of costs we pay in our mobile phones, which we know are coming down anyway, and for our home internet connections. So yeah, as these scale, they will continue to come down in costs. Absolutely. And also too, as people get more confident in using the technology. So this idea of remote monitoring of a rainwater tank as to whether it's working or not, it could potentially get to the point, like in Aquarevo, we will go in and we'll maintain it once a year, whether it needs it or not. Obviously earlier if we detect a difference, but because you're monitoring it remotely, that could turn out to be 2 years, and there's your potential, human saving in that space as well. So definitely.
Okay, and then in terms of, I guess this is more like personal modeling tools that are available for the smart tanks. Is that available if you're just a resident who wants to look into it?
So is the question if an individual resident wants it?
Not, is there a modeling tool available for smart tank behavior on continuous simulation? That's
I think I'll probably take that one, Dave.
all right.
Yes, so we haven't developed like a formal tools, but we did share some of the code of my modeling along with one of the paper we published in 2018. So if you're searching online about, I think I'll probably share the link of the paper a bit later in the chat box. But yeah, we did post some of the code online. So if you're interested, just have a look.
And are there any opportunities for utilizing this technology for large harvesting systems?
Yes is the answer. And so it depends how large you want to go large. So our Water's Edge office has an 80,000 litre tank. In Fisherman's Bend, we're up to a 50,000 litre tank. Yeah, what we're looking at doing within the Monbulk catchment, those Birdsland Reserve and Belgrave Lake. Beth, how large are they? We believe we'll be looking to control those as well. How big are they, Beth?
I wouldn't know off the top of my head, sorry, David, but they're reasonably, they're reasonably large lakes, I guess. They're much larger than your typical rainwater tank, definitely. Yeah.
There's also the Lincoln Squares project that the City of Melbourne have undertaken with Storm Consulting, not using IOTA and Southeast Water, a different form of technology, but a similar theory. And that's the same thing. That's a stormwater harvesting with a release for flows coming through. I'm not sure of the tech they used on that one, but that was definitely sizable. So yes. In general,
thanks, Jamie. Spot on. Yeah, that's been a great project there. Yeah, not us, but anything that helps support the proof of principle there. They took a very much a built from ground up kind of. I think they've got full on large PLC controllers and things like that. So we're more being able to condense it down into a smaller size. Basically, any size of system that it has a valve that we can control or a pump that we can provide power to. So, that might be a sluice gate that can be activated, a valve, regardless of its size. Pump, doesn't matter, as long as it's got a power that we can tap into, it can be controlled.
I have a question here regarding ongoing maintenance and management of tanks. Do you have any preferred options and what you'd like to see in the ideal world, I imagine.
Well, in terms of ongoing maintenance of the tanks, as I mentioned before, as we do maintain our own house, the tank will be part of the house, and it is currently expected that the resident would be maintaining the tank, and to the standards. And once that needs a replacement, then at that time possibly we can look at contributing. That's the only thing we are considering now.
I think that's a lot of the questions that I can see. How large a catchment area is required for this to be effective? I'm not sure which one this question is pointing to. Does anyone have any ideas? How large a catchment area is required? I guess larger is kind of better.
I think, like Dave said, I can't agree more. This technology really not, depends on how much tank you got. It's, as long as it's feasible to install electronic devices, in theory, any tank could be controlled and show their benefits. It's just the matter of how much benefit you have. So imagine, if you're thinking about small tanks, for example, the trial site that mentioned in Caulfield, that's like 70, 60 square meter roof, and the tank size was around 3 kiloliters. So imagine that's pretty standard for Melbourne residential house scale. You can go larger, of course, that's better.
So you can go, so what's the largest one you've looked into, I guess?
I think probably the other way of looking at it is in the Monbulk catchment, and Beth, correct me, Daniel, correct me on this, but I think that initial modelling looked at, assumed tanks at every second house in that catchment, and it assumed, I can't remember the percentage, it assumed it maybe a 50% of that roof catchment. In Aquarevo, we're assuming every house and 100 square metres, which is roughly 50% of the roof space in that side. Do you know what was assumed in Knox?
So at Knox, what we've done is we considered 4.5 litre tank minimum. So that would contribute towards the good, decrease in the flood. If we go any lower than that, it doesn't provide you that benefit.
And can you remember, Si, was it every house? Was it every second house, every fifth? Can you remember what percentage of roof space? I can't remember off the top of my head.
Well, that was 60% of the roof space, and 80% of the flood or the roof, runoff is captured within that tank. Yeah.
We still have a lot of. Oh, yep. Continue.
I was just going to say the 80% and 50% of roof catchment in Aquarevo, we deliberately limited it to 50% because without getting too technical, if you want to catch 80 or 100%, you're generally talking about what's called a fully charged system, so that you have to run part of it below the ground, maybe even under the house, to fill the tank. And in Aquarevo, we didn't want water sitting around in a charge system, so that's why we only caught 50% where we could have the runoff directly into it. 80% will be a challenge in a retrofit system as well, if that's going to be fully charged. But saying the size of the tank in Knox is a real enabler as well, bigger than the ones we put into Aquarevo.
Yeah.
I think the other thing to point out and jump in, guys, that probably wasn't touched on so much is that the roof system is only designed to carry a 1 in 20-year event. So the impact of all of these systems are sub 120-year event, but when we're getting a lot of nuisance flooding and those kind of things, I mean, they're ideal and fantastic, but this isn't a, solve all our 1 in 100-year problems. Correct. But it's certainly going to impact our waterways, our health, our low peak flows and those kind of things in that sub 120-year sort of mark.
Yeah, absolutely correct, Jamie. Agree.
I have a question here relating to would homeowners get any long-term financial gain or reductions in their water bills?
I would definitely say so. If you're using the water from the tank, that is whatever is saved within the tank. So even say, suppose the 4.5 liter tank's there, but you have 3 liter water saved in there, and you're using for washing and all of the purposes within your home. So you're saving that much water per day, which will be saving for your water bill. And if you continue doing that for long term, that's a long term saving for yourself.
So is correct. And unfortunately, the saving from using rainwater doesn't turn the business case. It doesn't pay back the tank. Water is still, you got to be careful how you say it. People in hardship wouldn't agree, but water is relatively cheap, drinking water. And so the saving in rainwater, it takes a very long time to pay back a rainwater system just on that kind of substitution. There is also a saving too in the corresponding sewer charges as well that go with that substitution, because your sewer charges are actually based off how much drinking water you bring into the home.
Yeah, and relating to that, we've got a question about smart tanks and development. Will authorities such as Melbourne Water consider a reduction in offset payments by the developer? Does anyone have anything to comment on?
Hey, is Sarah or any of the Melbourne Water guys still online?
Can't see it there at the moment.
No.
But I would say, David, you could be able to specify some of your experience with the Aquarevo over there, working with the developer, and what you were thinking at that time. Yeah.
Yeah. We were unable to negotiate with Melbourne Water at any kind of offsets in advance of the Aquarevo development. But that's because it was largely unproven. So that's part of the purpose of Aquarevo and getting the data now that we're starting to scale into more houses to actually demonstrate how much water is being held back, is being retained, is being discharged at different points. So yeah, it's about putting the data on the table, and hopefully that will lead to offset kind of discussions down the track. It's pretty complex, you know, a lot of sympathy for Melbourne Water trying to work all this out, but at least we'll be able to put that kind of data on the table and start that conversation.
I think it comes down to the longevity and ability to keep things maintained and working. I'm not saying that wetlands and rain gardens are maintained and working all the time either, which is some of the problems we have with these discussions as well. But yeah, it comes down to trying to put it on title, which we've got over with a lot of these things with design guidelines that are happening in a lot of estates and what at the moment. I know Casey have been doing a lot of work. I don't know if Norsheen's still around, putting rainwater tanks on title as a mandated thing, so that once someone comes in, lives in the house for 20 years, bulldozes it and comes back, they still have to put the same initiative back there to achieve the same outcomes. It's about trying to keep that sustained and rolled over. Generally, as a wetland's in, it's in forever. There's not a lot of change that generally happens with that. There's a bit of flex and movement that can happen in the residential sector that I guess we need to factor in. And that's kind of where Melbourne Water are a bit hesitant too in that system. But yeah, I've definitely started some discussions with them too in my own business, trying to get some offsets reduced based on different initiatives such as rainwater tanks. And it is a challenge, but there needs to be something in place to make sure that they're there forever. And that's where I think we need to keep moving and pushing that sort of discussion along.
And what is the best way for anyone to get in touch with IOTA?
Pretty simple. There's any number of ways. They got a pretty good website with contacts on that, or email me and I can pretty easily pass you on to those guys. Yeah, no drama at all.
All right.
I guess the question is, IOTA is a a subsidiary of Southeast Water, but that doesn't mean they only have to work within the bounds of Southeast Water. Their products and technology can extend beyond that, can't it?
Yeah, that's exactly right, and that's why they were set up. Southeast Water is limited by our regulatory obligations and our regulatory boundaries. IOTA has special permission to have discussions with anyone that they like outside of our area. Look, sitting on the Southeast Water side of things, I really appreciate it when they come back with additional feedback and customer feedback on our technology, and we do our best to build that in as we go as well. So it's pretty interesting times.
I think it's great. How are we going, Grace? Any other questions we think?
I think we've covered so many questions. I think, yeah, we've covered a lot.
I think there was a minor point. Carolyn Carvello just tapped me and said that Si was referring to 4.5 litre tank, but what he meant was a 4.5 kilolitre tank. So they're not tiny little tanks on these properties. They're actually 4.5 kilolitre tanks. A minor thing.
Yeah, I mean, I think most people would have picked that up. Yeah, I'm not sure if, I think that might be the conclusion of our informal session since we've finished all these questions. Does anyone have anything else they want to add or say? All right, in that case, I might get Jess to, to switch us off. All right, thanks, Jess, and thanks everyone again for getting involved.